Okay, hello everyone. Welcome to a new session. So, in continuation of our previous session that we discussed heap data structure, today we will see some application of heap. There are many real cases that we can use heap, but the most famous ones are we can use the heap in priority queue, in heap sort, and in some graph algorithms that later we will go through them. But for priority queue, first of all, you know, queue is a data structure that works based on first in, first out approach. Uh, the one who comes in the queue first, he is served and leave the queue first. So first in, first out. Or let me show you some pictures. Queue data structure. Yeah, see, for example, this one, there is a front part and there is a rear or end part. So anyone who comes in this queue first, he leaves the queue first. Suppose you are in a supermarket, and when you are done with shopping, then you need to go to the register and get checked out by a cashier. So there, people are standing in line in queue. Anyone who comes first in the queue or in the line, he is served first, he is checked out first. So that is simply a queue, how queue works. But sometimes you set a priority on your queues. That means you do not just work based on first in, first out approach. For example, in this case of a supermarket, sometimes you may say that, well, let's allow women and children to get checked out first, or older people get checked out first, because we all respect them. So now you serve based on their uh, like whoever is older, they get served first. So that is how you use the heap data structure in that scenario. And that is a queue, but that is a priority queue, because in that case you have used heap data structure. And heap data structure, it is always either max heap or min heap. In that case of that supermarket, because you serve based on the older ages, so you make it a max heap. Because whenever you make the max heap, you put the older one in the root. So when you extract or remove an element from the heap, it is always that you extract from the root, not from any part of the heap. Always you take the root. And when you take the root, you put the last node in place of the root. And then you heapify that and make it a max heap again. So it continues like that, and each time you are getting the oldest one and the youngest one comes at the end. So that is how heap is used in priority queue. And also heap is used in sorting. There are many sorting algorithms. Some of them are really good, and some of them still have some use cases. Heap is also a kind of algorithm that we can use in sorting. Suppose you are given an unsorted array like this, and you want to sort this. You want to sort this ascending from smallest to largest one. So that means you make a max heap, and then you take the root and put that at the end of the array. Again, you heapify it, make it a max heap. This time take the second largest and put in the second in position, and you keep this process until the last element in the array. Now let's see how it works in example. So when you define your heap sort, so first of all, right now this is already a max heap, but most of the time you are given an unsorted array and just you are asked to sort this. So first you have to make it a max heap, build max heap. So first you need to make it a max heap like this, then you start extracting elements from the root. So, however, in order to uh, go a better approach, a smart way, you don't traverse all the nodes or all the elements in the array. You only go through all the parent node in this heap, or the internal node, not the leaf nodes. Why not leaf nodes? Because when you are checking, for example, this number 20, you already have access to its children. So you don't have to go here, like you don't have to define a loop to check this one also, because it takes more time and more space. But when you are here, you already have access to both children through this one. And when you are here, you have access to both children from here. Or when you are here, you have access to both children. So you only traverse the internal or parent elements and compare them with their children. If they are already greater than or equal to their children, fine. If not, you swap them. That's it. For example, suppose here is 50. When you check 16, so you see that, well, it doesn't have the max heap property. Then you swap these two. And later when you are checking 25, when you check 25, you say, hey, here is 50, but here is 25. Again, it doesn't have the max heap property. Then you swap this like this. See how the largest element even comes to the root without going to the leaf node. So you only check the internal node. And how can you get this? You get that through this mathematical formula. You take the length of the array divided by 2 minus 1. That gets all the internal or the parent nodes. For example, in this case, so we have 1, 2, 3, 4, 5, 6, 7. 7 elements divided by 2. That is 3 point something. You don't get the decimal part. You only get the integer part. And that is 3. 3 minus 1, 2. That means from index 2 up to index 0 is the internal or the parent nodes. Let's see, is it really like that? So it is index 0, 1, 2. So that means these 3 should be internal nodes or parent nodes. Are they really? Yes, they are. See? So that means like this, we can get all the parent or internal nodes, and we compare them with their children and heapify them. So we call our heapify method. So in the heapify method, we pass the array, we pass the length of our array, and we pass the index of the farthest node that we are checking. For example, we start checking from here. That is index for the 16. So come to the heapify method. So every time when you get these parent nodes, so you need to get their children and then compare them with their children. You already know how to get their left and right children. So now when you get the index of 16, you suppose that it should be larger than its children. So you keep its index and name this variable largest. You keep that index in this variable. So now you check this node with its right child and when its left child. So first, now come here, check it with the left child. So left, the index of this 5. So the index of 5 is 0, 1, 2, 3, 4, 5. The index is also 5. Is 5 less than 7? Yes. And array left, that means 5. Is it greater than array largest? Is it greater than this? No. So this doesn't execute. Then you check the right one. Is the right one this index 2? Is it less than? So the right. index 2, 0, 1, 2, 3, 4, 5, 6. And is 6 less than 7? Yes, of course. And is array right? Is 2 greater than array largest? Is it larger than 16? No. So that means this part also doesn't execute. So if this two part doesn't execute, this part also doesn't execute, because that means the large I, this 16 is the largest, and when you check this, you say is largest updated or not. It says it is not updated. But in case it happens that it updates somewhere, so you make a swap and then heapify again. So when you are done with the heapify, creating max heap, then you start extracting the largest element. For example, from this part, now that we have our max heap, so we need to traverse through all this array, and each time we need to extract the largest one. So let's start from the last one up to the first one, and each time swap the first and the last one, because the first one is the largest one, but the last one we do not care if that is the smallest one or not. But that is not our focus. The focus is the to root, and the root is the largest one. You swap these two. That means put the largest one at the end of the array. For example, here put number 25 here and number 2 here. Swap that two like this. Number 2 here, number 25 here. So you swap these two. When you swap these two, so right now you got the largest element in the last position. So, but the rest of this heap doesn't have the max heap property, because right now you see the root is number 2 and it is smaller than its children, and then these two nodes are greater than their children. So that means it lost that that heap property. So again you heapify that. You call your heapify method, you pass the array, you pass the index of the node that you are checking. So for example, the index here is so it should be 6, yes, and also you pass the index of 0, which is the first one from 2. So when it comes here this time, so for example at this point you have the index 0 here, and you put this in the largest. Well, you suppose that it should be the largest one, and then you get its children, its left and right children. So you got the children also. Now you have access to 20 and you have access to 16. Now you compare this with its child node. You say that is left less than n, so left is 0, 1, left is 1. Of course 1 is less than 6, n is 6 from here when we passed, and array left 20 is greater than largest. We thought it should be the largest, but when we compare here, now we see that it is the largest. It is larger than this one. Then we update this variable. First we had the index of number 2. Now we update that with the index of this left child. So, and then you come here, you check with the right. So you say is right less than n, so right it is 16, 0, 1, 2. Of course 2 is less than 6, and you say array right is 16. Is it greater than array largest? Array largest, now it is updated to this one, because you updated largest here. So that means 20 is here now. So is 16 greater than 20? No, it is not. So this part doesn't execute. Then you come here now. You say is largest against I. Yes, when we passed I it was 0. We had passed the index of number 2, but here that updated to index of number 20, and number 20 is 1. So now if the largest is updated, that means we need to make a swap. So we get the array of I, which is 0, which is 2, and swapped it with array largest, which is this one, number 20. We swap these two and keep heapifying again in order to check all the elements. So again, the rest of the array is heapified here, so this loop continues. So first I checked, so the last one, 2 and 25 got swapped. This time we ignore the last one, because you see that I starts from the last index, and each time the step is -1. That means we go from, for example, 6 to 5, and the first time it was checking the last one also, but this time it checks this one. So now the array is updated like this, and this time, so when we heapified here, 20 came here at the top. When we heapified that, 20 came at the top and 2 came at the bottom. Again 2 got swapped with 9, 9 came here and 2 came here. So you swap, this time you swap, so number 20 came here when we swapped here, 20 came here, number 9 came here, and number 2 came here. So this time when you swap, that means you swap 5 and 20. You put 20 here and 5 here. So again, when you heapify this, you put, that means you take the largest one and put at the end of the array, and then put the number 5 here. So that means number 5 here now, and 20 here. So now you see again it lost the heap property. So again you call heapify, and this process continues until the last one. Like you see, each time you get the last one and you put that at its right position. So you keep this process, this operation doing until the first element, and this is how you can sort an array using the heap data structure. I hope it was clear enough, so you can process this up until the last one. Now I believe you have the idea, because the rest of the process is the same. But still, if there was any confusion or question, ask them in the comment section. I will go through your comments and I will answer to the best of my knowledge. Until the next session, have a nice time, everyone.